Hi, I'm Harper Carroll from Harper Carroll AI. I got my undergraduate and graduate degrees from Stanford University in computer science in AI. Then I was at Meta for 4 years doing AI, and now I am an educator teaching AI online.
Do you see a Neuralink in the future that's more robust and more well-tested being something that you would be okay putting under your skull?
Oh, goodness. I don't know. I don't want to say never. I never say never. I don't know how the technology is going to go. Maybe it'll be really easy. Maybe it'll just be a sticker and it won't have to go under my skull. If I actually had to go implant it in my skull, I probably wouldn't. I'd rather just be a lot dumber than everyone else and go live in a mountain somewhere.
Yeah, I mean, if you get over kind of the question of whether it's safe or whether you want something in your brain, what do you think it would feel like to have your actual thoughts extended into a trillion extra parameters, I guess, that would kind of mimic your neurons and that feeling of seamless communication to a larger brain?
I don't know. I mean, it would be like having everyone's brain inside your own, I guess. And maybe it would be cool to have a way to differentiate, this is your thought. And then now loading, the everyone else's brain, the AI super brain. This is what the super brain would say. I don't know what that would feel like.
But would you feel frustrated if you said oh wait, since you're not connected and somebody says oh, what was it that was written in the Constitution in 1776 and you kind of generally know it has a lot to do with our country, but another person who's got Neuralink installed could read you any paragraph to perfection or to relate it to other industries of science, and you're feeling behind or limited or sad that you can't think that way?
I don't know. I mean, I could just use my phone. I could just be okay, give me an extra couple of seconds to pull it up on my phone. Or maybe I'll have an AR glass to do that for me. Or, I mean, I don't know. I can't say, because maybe there's some way that doing it in your brain is better and you can link it with the different neurons, and it's so much better than having it be on a separate brain outside your own brain. It could be personalized to your own brain. I don't know. Elon is the mastermind that I am not. He can think outside the box, unlike anyone I'm aware of.
So from your perspective, what are the most promising areas that are emerging in the AI field, where investments should be made, and what kind of direction is it going?
Imagine a brain that just had everyone's knowledge in it. And it would more heavily weigh on the knowledge that everyone has. So if you have some outlier of someone who just believes something that's wrong, it's not likely to have that skew the model because it's trained on everyone's brain. So, if everyone thinks the sky is blue and one person thinks it's yellow, it's probably the likelihood of it thinking that the sky is yellow is so unbelievably small. It's not going to index on that person. It's going to learn from the masses. And so when you're talking about diagnosis, you have the brains of everyone's medical history and everyone's what their diagnosis was, and how was the shape of the condition of their body and their blood and whatever, and then what was the diagnosis, and it can draw these connections that people could never draw before. And I think what's also cool is we have people who are specialists in history and science and religion, but imagine this is a brain that can have all of that in one brain, and so it can draw connections between fields that no individual human really ever could, because they couldn't fit that amount of knowledge in their brain.
So in the race towards artificial general intelligence, do you feel like OpenAI is leading the pack? Do you think that is that the model that you tend to use the most, or are you a fan of Claude and of what they're doing, or do you think someone else is going to be the dark horse in this race?
It's so hard to know, because I feel a lot of what people are doing with AI is hidden away, or it's falsely represented as being better than it is. For example, I think Google released a video that was actually, everything was hard coded. It was supposed to represent the capabilities of their large language model, but it was actually that was not truly a demo. It was just a hard coded example. So that's an example of misrepresenting how far you've come with the model. I don't know if OpenAI is the most advanced. Perhaps they are. I don't work inside that company, and everyone's so secretive. It's hard to know. I will say that in terms of the models that are out right now, I and many others agree that Claude 3.5 Sonnet which just came out by Anthropic, is like the best model out there. It is really useful for creativity. It's just across the board interacts more like a person. It seems more real. It's more thoughtful. It's more creative. No, it cannot generate images. Like if you pay for ChatGPT, they mix in their image generation model. So if you ask to generate an image, they'll use DALL-E, which is their image generation model. Claude can't do that. Claude also does not have a calculator built in like ChatGPT.
And what about Grok and Gemini? How do you feel like do you think one of them might be the first general intelligence?
Great question. Grok, I know Elon is working very hard on creating a data center with, I think he said 100,000 H100 GPUs. So H100s are NVIDIA's most powerful graphical processing unit, which is a chip that you can use to train AI models. We can talk about that more. But so that's the most powerful one made by NVIDIA. Having 100,000 together to train a model is, as he says, the most advanced data center or computer cluster in the world that exists. So theoretically, you could then build the most powerful model ever. You could have more parameters, you could have more data, whatever. Because right now, the race to the top is kind of just compute, so they say. People think that having more data, bigger models, that will make smarter models, is just making them bigger and bigger and bigger. So theoretically, I mean, Grok could get to the top if they have the biggest compute center.
So maybe.
Who knows?
Can you explain RLHF? This comes up a lot. It's the reinforcement learning with human feedback, and it seems to be how models hallucinate less and become more advanced over time. Like, what is that process?
Yeah. I also have another video on this. So this is a system where the human helps guide the model towards answers that are more desirable by the human. So maybe they sound more human-like, or they are more friendly or helpful, or not like problematic, or using curse words, or giving dangerous advice to people, like, telling you how to make a poison or something. And so what you do is you are giving, what the process typically looks like is you give the human two answers, and then you have the human choose which one is the better answer. So given a question, there's two, and then you would say, like, which one is more helpful? Like, you would choose kind of what metric you're optimizing for. Maybe there's helpfulness, maybe there's like sounding more human, whatever.
So it's not an error in the same way you were describing them earlier?
No, you're getting rewards. So in reinforcement learning, you get rewards. It's kind of an analogous system to error, but rather than an error, you get rewards, and you want to maximize your rewards. So yeah, I talk about this in day one of the 10 days, whereas there's different types of machine learning. One of them is reinforcement learning. One of them is, supervised and unsupervised and self-supervised learning. And with supervised and self-supervised learning, you have like a loss, an error. With reinforcement learning, you have a reward function, and you're trying to maximize your reward, typically into the indefinite future. And so rather than thinking like, oh, I'll do badly, or I guess you could say like, I get a negative reward if I do this versus this, which is kind of, I guess, like a loss, but it's just different.
You know the phrase where people say like it's a carrot or a stick, you either like reward them or punish them. Is RLHF the carrot and then error rate and gradient descent the stick?
Oh, that's kind of cool. The carrot. Yeah, I kind of like that. Although, except that in reinforcement learning, you can still get like negative rewards. Like if I were to touch a stove as a baby, I would get a reward of -10. But if I were to just do nothing, then it's 0. So in the future, I would probably do nothing. So it's not really like a carrot. Like I'm not getting a carrot for doing nothing. It's just 0. But at least I'm not hurting myself.
What about GANs, like generative adversarial network?
So GANs have a generator and a discriminator. And they, rather than having like the human interference, they kind of operate on their own. They're really good at generating data based on style. So I give you this image and I say, here's a Van Gogh. And the discriminator says, that's not a Van Gogh. And the generator says, oh, shoot, why is that not I didn't trick you. Okay, well, I then need to learn how do I make this look more like a Van Gogh? So I learn more about the distribution of Van Gogh and how the pixels are relate to each other and how I can then generate a better Van Gogh. And then the discriminator, so say the discriminator gets this and says, oh yeah, nice Van Gogh. And the discriminator and the generator is like, wait, I tricked you. The discriminator then has to say, oh, I'm not very good at discerning. I don't really know what makes a Van Gogh then. I need to get better at figuring out what makes a Van Gogh because you just tricked me. And so it's these two systems that are both optimizing to get better and better and better at their own thing. And so then you're able to make things like deep fakes where the generator creates a video and is able to trick the discriminator. Says like, oh, here's a video of, Biden saying something. And the discriminator says, yes, that is indeed Biden, even though it wasn't. And then the discriminator would then get better and better. But you reach a point where you're done training and you can deploy these in the world, but then you can make these videos that are like can really fool you.
And can you explain why CPUs and GPUs are different in terms of training and why GPUs seem to be more important and why there's sort of custom chips being built now by almost every major frontier model?
Yeah, so GPUs are better at matrix multiplications, and matrix multiplications underlie machine learning models. So remember, we talked about how model architectures are really just these parameters, and what you're doing is you're just passing the data through a set of functions to then get the output. And what you're doing is you're tweaking the variables of those functions so that it's appropriately transformed given those variables to get the output. So what those actual transformations look like is mainly just matrix multiplications. So like, again, with the example of a image, you have a 2D by 3. So it's a matrix in the sense that it has 3 dimensions and it looks like stacked squares.
And a matrix is like tic-tac-toe, but with numbers in there, and then you multiply the two together.
Yes, a matrix is like tic-tac-toe stacked together, right.
And a GPU is better at that kind of math than just normal multiplication that's written in a linear way?
Yeah, it's really good at these matrix combinations. And that's what it's optimized for. So they were originally made for like video games. So video games are also matrix operations because it's like, as we said, an image, and this is like a moving image over time, right? So it's also a matrix, it's a video game, and you have to do these operations on them. And so graphical processing units, they're really good at these kind of graphic processes.
Oh, so they hijacked it to make AI training and inference runs because it was so similar, but now we're at such an extreme that they might want to make chips even better at matrix multiplication?
Like LPUs are a new type of chip. It's for, I think it's called a language processing unit, specifically for inference. So it's like at no longer training, it's at like in deployment. So out in the world, it's done. It doesn't need to update its internal parameters anymore. It's done doing that. Doesn't have to do gradient descent.
Oh, wow. I didn't realize we're going to probably end up with chips just for inference and for training, huh? Even that's such a different process?
Yeah. So inference, they have chips now for inference by Grok. Different Grok than xAI's Grok. It's called GROQ. They have the fastest chips in the world, I think, by a lot. They run these models at inference so quickly. So they're good for specifically for transformer-based models. So typically we're talking about large language models. And yeah, they're just, it's like lightning speed. And you can try out Grok at grok.com. They have a little playground where you can, once you log in, on the top right, you can see the different models and play with them and just see how fast they are. It's faster than using anything like if you go to Claude's website or ChatGPT's website, it's like, it can write a whole book in like a second, like an entire book in a second.
What do you get the most sense of purpose from in your life?
For me, it is teaching. And I think I spent a long time trying to figure out what gets me riled up, what gets me so excited and happy. And there's this book called Mastery, and he talks about looking back into your childhood to see the things that you're kind of called here to do if you think that way, or just that you're kind of, if you don't think that way, that you're kind of coded to do. Like, and when I was a kid, I would obsessively teach everyone around me what I knew. So like I was teaching
so it was built in.
Yeah, I was like teaching my peers how to read when we were doing reading. I like started to read a bit earlier than everyone else. So I was like, rather than going and sitting in a corner and reading, I was like teaching them like, oh, hey, this is what I found useful for that. This is how I thought about that. And it was helpful because I was kind of their peer as opposed to like some old, when you're that age lady, like trying to understand, relate to a child. I guess they have, formal training, but I was 3-year-old. So I understood some of the issues with that, or however old we were then, 5. And then like I would go do science experiments at school and come home and grab my little sister and like find the materials in my house and be like, we're doing the experiment again. Or like I would teach her math. And I just love teaching, and when people like it. And like when I learned yoga, I would do yoga at home. I was a kid when I started doing yoga, and I would like have these yoga sessions, and I would have my family come sit, and I would like do the whole thing. So I love to teach. And when I started getting into teaching again recently to do coding tutorials for a startup I was at.
Oh, did it bring you that nostalgia every day when you're...
Yes. It brought me that joy that I was like, whoa, this is it. I used to also love to make videos. I made videos on YouTube as a kid. I would edit. I used like Final Cut Pro. I was obsessed with editing and making videos. So this is kind of the combination of everything that I loved as a kid.
Do you get some kind of a sense that the equivalent of a reward function for a human is flexible as a child, and whatever your kind of earliest stimulus is becomes something that can drive you for purpose later in life? I say that because I have a friend that just loves cooking, right? Just loves the kitchen and ingredients and watching people's faces when they eat. And then I was surprised later when I found out that she also was that child with the easy bake oven and made little fake hot dogs for their friends. And I wondered, is it not ingrained in us initially, and it's something that we learn early on that can power our purpose?
Well, this is probably better for like a child development specialist, but I can tell you as myself that my memories of, and I don't have any kids, so I bet maybe, I don't know, but my own experience of life, I was given various options. My parents were really lovely in that they took me to, I tried all different types of sports. I played soccer, I played basketball, I played all the things. They tried to teach me piano, which I did not like. I tried that at a young age. I went to art classes, and my parents were really great in showing me all these different things. But gosh, I did not like so many of them. I never liked art, like drawing art. But acting, I wasn't exposed. I loved acting as a kid. I used to like repeat the lines back to the characters on TV. No one showed me that. They just turned on the TV. I was the one like as a little, very small child repeating lines back on the TV. Like I found that myself. My parents had no, understanding of that. So I think maybe not. I don't think it's just what you're exposed to. I think you kind of like find it and then it sticks and then you love it.
Do you think deep down that Claude and GPT-4 have something like an early reward function? Anything like in the future that would be considered nostalgia that the system might kind of have deep in its core, some kind of semantic meaning in the same way?
Ooh, wait, talk to me more about this.
The question I kind of wonder is like, will a large language model ever have the ability to ingest a joke and sort of laugh to itself?
I think that's kind of cute, laughing to yourself. I don't know. Maybe the researchers would have a better idea on this, but like maybe as we get into agentic workflows and that the models actually like have an action that they do, or like they can like do something rather than just sending you back a response, maybe that'll open up to more like responsive actions or things outside the scope of just like input, output,
Yeah, especially just with alignment. I know like kind of constitutional alignment is, I guess, about having two sort of systems deep down checking each other and trying to keep it aligned. And I don't know if there's anything to learn from alignment from the way humans find purpose, or if we seem to also be aligned from our parents, but we also seem to be aligned physically. Like when you said that child touching a stove gives a negative reward, that's built in above the learning level. and certain hormones and socializing skills seem like they're all built into our genetics. So I don't know. I don't know if there's any way that we can build a safe future with an aligned AI because of something we could learn from biology.
Yeah, the biology thing, Fei Li talks about this. She's, considered like the godmother of deep learning. She's great. She talks about how she never thinks AI is going to, have like human level intelligence, or rather like consciousness, or whatever it is that the argument is, because there's no biology. Like, we as humans have feelings and are so influenced by the current state of our biology. And we have hormones, as you were saying, and like an AI model won't have that. And so it like inherently can't be us.
And do you feel the same way?
Yeah, I think she's right. I think there are so many factors that influence us, that make us like biological systems. We feel, we have these hormonal influences, and like, I don't know if, we feel love. I don't know if that's the nature of where love comes from, is a philosophical one, right? Like, is it underlying fabric of the universe? Is it a hormone, or not hormone, but is it like just something that is, some kind of different feeling that is for evolutionary purpose? If it's the underlying fabric of the universe, then yes, potentially models can feel love. If it is a biological system, then no, they probably don't, because they don't have biological systems.
So in principle, if we built something like Optimus, like a humanoid robot, and it had all of the similar like actuators to move the way we do, a similar human form factor, similar in the sense that if it touched a stove, we could give it a -10. We could say, like, if it's too hot and it normally would burn a human finger, we'll make it so that the robot burns its finger. And maybe something similar to hormones, but it would be digital. Like, when you're socially getting rewarded and attention, then you get, +10. And when you're isolated for too long, you get -10. And then you set some trillion parameter model in its equivalent of a brain, like physically in the actual computer that would be in physically the actual head. And it updated from like a randomized parameter setting. Then would consciousness emerge? Would it have truly human? Would it be a truly humanoid entity?
I don't know. I don't know. I couldn't tell you. I don't like, I can't say. There are some people, some hippies out there that like believe that, I talked to some guy once when I was in Hawaii who was like, I swear I can talk to trucks. Like, when cars are broken down, I can go make them better by just talking to them. And like, you know what? If that's his experience, totally, maybe he can. Like, maybe he has some way to communicate with them that I don't know. I think there's so much that we don't know about the nature of the universe.
What papers or authors have influenced you in the way you think about that?
I went through a phase of like learning a lot about a lot of different religions. Like maybe 5 years ago, I was studying a lot of like ancient and like religious texts, like in Hinduism and like the Kabbalah and like Jewish mysticism. And then like, obviously, like for me, I have a background in Christianity and, the hidden gospels and things like that. So I don't know, just learning and reading different things. And then my own experiences of being a highly mathematical, logical person my whole life. I grew up in New York City. I was very math minded. Besides doing like acting and art, I was very hyper logical. And I guess I was creative in that I like to create films and whatnot, but very logical. Didn't believe in any kind of like, thing. And then, I don't know, like over the years, I feel like a lot of coincidences, like things that are very unlikely to happen, have happened to me like back to back. And as someone who is so math minded, I think the likelihood of these things happening is so unbelievably small. And the fact that they're happening one on top of the next, kind of when I'm seeking, I don't know, not necessarily seeking it out, because that could be like, what is that, selection bias or something. But I've just had things happen where I wonder, and some people say that the universe, that this is all just a simulation. And maybe maybe it is a simulation, and maybe there is some kind of like, not just total, maybe there is some kind of non probabilistic attributes to it. Like maybe some things are hard coded or influenced in a way that is not just purely probabilistic, because then that wouldn't explain the things that happen to me that are super, super unlikely back to back to back necessarily. But anyway, so I don't know. I don't even know.
But out of curiosity, if you find yourself to be like a very logical person, is that what it's like in your own mind when you're talking to yourself? Do you tend to say something and then you think or before you speak, do you talk to yourself and say, okay, that actually doesn't make sense, don't say it, or that's not logical, that wouldn't like fit what I said earlier? So does everything in your head kind of need to be lined up in a nice kind of way? Is that what you mean by like logical? Like, what is it like when you talk to yourself inside your own mind before you talk out loud?
I don't know. I hadn't really thought about that. I don't really think that much before I talk out loud. Maybe I should think about more what I'm going to say, but
like, are you fairly kind to yourself if you make a mistake and you're embarrassed in your own head? Do you say like, okay, that happens, like people say things that are wrong? Or do you tend to be more like, dang, you should have known that because like they told you that earlier, don't say that out loud type of person?
I think it depends on the situation. Like if I've forgotten something someone told me about themselves or something, maybe I might be harder on myself. But I don't know. I've definitely gotten less hard on myself over the years. I think we as humans all make mistakes, and we're just like doing the best we can, and we want to hold ourselves to super high standards. I feel like I already hold myself to a very high standard of execution. So if I make a mistake, I know that I did my best, you know. Whereas if I am slacking on whatever it is I'm doing, then I'll be much harder on myself.
You kind of rate yourself based on effort, kind of. You're like, look, I put a lot into that. I thought through to a reasonable degree. And if it doesn't work, it still doesn't work.
Totally. Yeah. It's like I did my best. But if I'm slacking and I didn't, then yeah, I'm going to be harder on myself.
Yeah, I bring that up because sometimes I think of error rate. Like, you know, in my head, when they talk about outputs from LLMs, thinking step by step or being like, check yourself, like think step by step about your answer. Some people, I think, kind of just, they give you that quick answer, and sometimes there are more mistakes, and other people seem to talk a little more slowly, and they come up with their answer in their head, and then they check it a couple times. And to me, I've kind of always thought there was a little bit of an analogy between like LLMs that do that kind of multi-step reasoning and humans that do multi-step reasoning, and the quality of their output, I guess, versus the quantity and the computation that, you know, there's trade-off for it.
Yeah. I think actually, though, I was reading this somewhere. Forget, a sign of an intelligent person, or I think it was like in a gifted person's like thing. They can skip. So if you go A, B, C, they'll often go A to C and skip B. And then, so most people will be like, what? Like, how do they get to C? Like, what's wrong with them? But they're actually, they didn't need B. But some people need B to see the link. And so I'm thinking of a neural network or a large language model, like it's slightly different potentially in the sense that like it's thinking probabilistically, but I think having that B is helpful for it to, because then it feeds it back in, right? And then it's constantly thinking again and again about what it just did. And then it's just like reinforcing that brain pattern or the logical thinking. And maybe actually it is right. And actually, no, I'm not going to say that, because I was going to say maybe it's like the gifted person and can just skip to C, but then we know it's wrong because of the benchmarks we have, the label data. But yeah, there are some signs of high intellect where they just skip. And so some people might be like, that person's crazy. Like, what are they even thinking?
Yeah, because they're making a link that you can't totally see.
Right.
The tokens that are word fragments. So king, queen, man, woman, and the semantic distance between them that can be sort of abstracted through calculations in a large language model actually have meaning to us. Because now I think about a model like Sora, and it's a bunch of pixels. It's a square pixels with frame rates, and it means nothing to me. But at least the words they already have a hierarchy, right? Like man and woman have already built into my head something that it has meaning. So I now can understand how these models work a little bit before they become below my abstraction level. Like we're kind of lucky that words are already an abstract level of knowledge, and that we can learn before we get into just like pure pixels and pure numbers where it kind of loses all meaning.
Right. You were like if you were to do some kind of dimensionality reduction and look at the location of like king, queen relative to man, woman, and like how you can kind of like add and subtract the locations together.
Yeah, because man and woman already have a meaning, whereas some other stuff doesn't. Just because I'm human and I already learned that, and it's in English, I have the benefit of slightly understanding the semantics, but semantic meaning between the distances.
I see. Yeah.
So in your experience teaching artificial intelligence, what concepts have been the hardest for people to grasp?
There's been a lot of debate as to whether AI models are plagiarizing. And I feel like what I want to teach people is that, to me, it's similar to a human brain in that it is learning from what it's seen before and then making something new. Like, we as humans can't create anything from what we haven't seen before. Like, everything that we do is kind of a blend of what we have experienced. That's why when you look at people's backgrounds, you can, determine how they behave based on how they were brought, and like, a certain reaction to something. If they react to something in a certain way, that can typically indicate something about their childhood or their past. And, you wouldn't expect them to react to something in a way that they've never seen before. And so models are kind of similar in that sense, in that they're kind of like brains that are going about the world and learning from the data that they receive, and then they make something new from that. Yes, you could emphasize certain artists or kind of like plagiarize in the sense that you try to make something specifically in the style of someone else, and perhaps a model could do that a lot better than a human could. In fact, it probably could. But I feel like that's less of a, I feel like they're more like human brains than we think, except that, you could argue that humans go about the world and have many experiences that are individual to them versus, an AI model training on data on the internet they're all kind of looking at the same thing. It's in the same data set. But I feel like people kind of struggle with that concept a little bit, where it's not just necessarily like copying. It's not copying what it's seen before. It's just learning and is able to extrapolate in a new way from what it's seen before as well.
Yeah, that thing about the human brain is mind-blowing. Like, I still think back to when I was playing around with GPT-3 and I asked it to divide two big numbers or do kind of a multiplication, and it was struggling with it. GPT-4 is better, but I was like, how, like, aren't you a calculator? Like, you're literally a program. Like, you've never built something in Python that has like accidentally got the number wrong. It just either failed or it got it right, So the way they are more like human brains, and the way some of the diffusion models like put together things in creative ways, it's very surprising. The AI has kind of come for the creative jobs before the kind of more process-oriented ones.
Yeah, well, so for large language models, they don't do well with numbers because that's not really how they work. They're looking at probabilities of like word distributions. So when you're looking at numbers, I mean, there's so many different, like, you don't tend to see a typical distribution when you're working with numbers. Like, yes, maybe something simple like 1 + 1 = 2, but you could, if you're looking at a training data set of numbers and of calculations, there isn't really like you wouldn't expect 9 to come after 1 or 2 to come after 3. Like, there's no kind of long-term pattern. Like, looking at however many X numbers before, can you predict what comes next? That data is less prevalent online. Like, we don't have just like tons and tons and tons, like millions, billions of samples of just math equations in, addition or subtraction or division, or like if you're trying to guess the output of an equation simply based on what you've seen before rather than actually manipulating the numbers and doing math, you need a lot more data on math than we have now.
Why is it that when I give the same prompt twice to a large language model, do I get different answers?
When you give the same prompt twice, it's because what you're doing at every step of the output of the large language model is you are sampling from the possible outputs that it makes. So a large language model produces typically, historically, one token at a time. And one token is a fragment of a word. And when you input your question, so you say, why is the sky blue? What the language model will do is take that input, pass it through its model, and then it will produce one token at a time. And it will then pass the total sum of the tokens in again to get the next output. So for example, if you were to say, why is the sky blue? It would, the first token it makes would probably be the space. And then the next would be, it would then pass that in and then say sky and then pass that in. And however, at each token generation, at that layer at the end, and typically throughout the whole system, depending on the way the structure is, you have a probability. And you're sampling from the likelihood of all possible words that you could possibly output, the language, the corpus of knowledge of the model. They have, every word the model knows in its brain. It creates a probability for each of those words. So given the past, input, which is your question at the beginning, just your question, what's the most likely output word? And then it samples from that distribution. So if you were to say, why is the sky blue? The likelihood of it starting with the, and then passing why is the sky blue, the, in, then sky, and then doing that again, why is the sky blue, the sky, and then the model would output is, and then et cetera, over and over again. It might choose that 1% probability of not being the. Because if it's just sampling, it might get that very unlikely but possible probability of choosing a word other than the. And there are different gauges that you can set, like parameters like temperature, which increases the distribution of those output words. So you're more likely to pick words that don't necessarily have the highest probability. It makes it more spread out. So you might see crazier answers. And again, since it's always based on the number before or the words before, if one case you pick the word that has 1% likelihood, that then changes the distribution of all the consecutive words.
I've always wondered about temperature too, actually. I didn't realize that just increases the kind of the bell curve of the distribution or something, so it can be choosing wider outcomes.
Yeah, exactly. It makes the less likely ones more likely, or rather it prevents the likely ones from becoming so extremely likely that you almost never pick something else.
Do you feel like there's an analogy to humans? Are more creative people just higher temperature predictors?
I love that. Yeah. The more chaotic ones or creative or whatever. Yeah, totally. I think that's really cool. It's the neural pathways are less ingrained in your mind. They say babies are kind of I've talked about this in my last podcast, but psychedelics are kind of resetting that phase of making other choices higher probability than typically your main choice. If you look at a pathway, you might take a new route. Yeah. And you always had a probability of taking another route, but it was so small that you just never did it. But then mushrooms or psychedelics or whatever would cause that other route to be taken. And they say babies are always tripping on mushrooms. Their experience is like that because
I see what you mean.
Yeah, they're in the training phase, right? And they're forming those pathways and they haven't become so hard set yet. So
yeah, I could see it. I mean, I've definitely never done anything with mushrooms, but it does kind of seem like at certain times in my life, it might be nice to pull back some of those, grooves and try to learn some new things faster, especially languages, or as new generations come up and they have new technologies. I find it harder and harder to just intuitively understand them the way I did when I was a kid. So
right, because of the openness, the parameter updating, the brains going in a different way. Yeah, I'm just thinking about this because there's a book called How to Change Your Mind about this exact topic. So
yeah. Do you think, I don't know, maybe in the future we'll have, I guess a pill, or maybe it'll be mushrooms or something that will help people with that. But then again, it also seems like a risk, because sometimes you have those grooves in place because they've been successful for you throughout your life. For some people, maybe other people have grooves that they hate and they're hurting them, and then they'd want them reset.
You're hitting the nail on the head. I think it's good. It has a lot of potential benefits for, therapeutic, like for trauma healing and like preventing trauma responses and things like that. And you would probably want it to be done with a therapist and under medical supervision. And I think there's a lot of potential for that. But yeah, just like recreational can be dangerous because you've learned for a reason, right? And a lot of your brain has been structured for a reason. So
Harper, can you walk us through the fundamental principles of how artificial intelligence operates?
Yeah, well, I guess let's make the scope a little bit smaller and talk about machine learning. So first I'll say machine learning, as you might have heard about it, is a subset of artificial intelligence. And so in the classical sense. So artificial intelligence is the intelligence of machines or computers or something that is not human, and specifically made by humans. And so you could have that when you just hard code a computer. So for example, you could tell a computer, if someone says hi, respond hi. And so if you're chatting with that computer and you say hi and it says hi back, it seems to be intelligent, right? It has artificial intelligence. But there's a subset of artificial intelligence called machine learning, and that is what we typically see in AI today, which is that it's actually learning from data. So it learns on its own. So rather than hard coding a response of hi, perhaps we were to feed it many chat transcripts and it would see, oh, when person one says hi, person two typically says hi back. So I'm going to say hi. So it learns to say hi. It learns how to respond from data that it's been given. And that is what machine learning is. And so when you hear of AI today, you typically hear about machine learning. And machine learning, again, is learned from data. So you give it data and it teaches the machine how to behave in the world given the data set that it's seen. And you can have computer vision models that, learn how to detect certain things in images, or you could have natural language processing models that work with language, like the large language models that we use today. There are many different types of AI models, but generally what you would say when you're talking about AI today is you're talking about machine learning and you're talking about models that are learning from data how to behave.
So is it incorrect if you say that a AI system is programmed to do something?
That's interesting. No, yeah, I mean, I guess when you think of programming, you're thinking of like hard coding, right? But no, I guess you could say like if the program is to learn from something and then it's programmed to given the data, that feels like a semantics thing. But I haven't thought about that. That's an interesting question.
Yeah, because when I personally think about the difference between something that's like programmed and something that's learned, I can imagine the most complicated for loops or if statements, all, thousands and thousands and thousands of lines of it. But then when you actually program, you're deciding where those are. And when you're learning something, to me, it's like approximating a function. So you're really getting into a conversation that's more abstract and you don't completely know with the same kind of understanding when a certain outcome is going to happen. So it seems different to me.
Yeah, I mean, having tons of if statements, that would be an example of like hard coding something, right? But then there are the ideas of, like trees where it kind of is continuous if statements, like abstracted away if statements. There are different types of models, but typically these days we use deep learning, which uses neural networks. But there are other types of like classical machine learning and AI. There's just so much in this field. It's very broad. But yeah, typically when you were to say like hard coding if statements, that would be a type of artificial intelligence, but not machine learning.
Can you break down the difference between like a parameter and a hyperparameter?
Yes. I also have a short video on this. But so parameter is what we talked about with the model, right? Where you have these neurons in the model. If we're talking about a neural network, we have the neurons in the neural network. So the layers are made up of neurons, and those are numbers that are then updated during gradient descent. Those are parameters. They are learned by the model how to, fit the input data into the output data, how to best transform it. Those are parameters. Hyperparameters are set by the engineer, by the machine learning engineer, the person making the architecture. They're not learned by the model. Hyperparameters are things like learning rate, which is how big of a step the model should take every time it updates its parameters in the direction of gradient descent, so in the direction of decreasing loss for each of the parameters. So there's a graph on this in my model training video that just came out, and there's a whole section, if you look, called parameters versus hyperparameters, so you can see the graph. But that's an example of learning rate. You can see the graph of learning rate. There's things like batch size, so how many samples you feed to the model to update the parameters. The number of epochs, so how many passes you go through the data set when you're training. Iterations, how many times, how many steps, things like this. So there's a lot of things that we set on the engineering side that dictate the performance of the model. And those tend to be sampled. So what you can do is you could do something like grid search, where you create numbers, you make a set of possible values for each of those hyperparameters, and then you just make a set of every single possible combination of those. So if you have 3 possible ones for, step size or learning rate, and you have 3 possible ones for number of epochs, maybe you want to do 1, maybe you want to do 2, maybe you want to do 5, or whatever, and then you combine them so that you set the learning rate to 1, you set the epochs to 1, and then you have like a set of all possible combinations. Then you would train a model for each of those combinations and see which model does the best, which is, as you might expect, expensive. Every time you increase one of the hyperparameter options, you're like multiplying all the other ones.
Gosh, so is there somebody at OpenAI or some team that has to hard code in a hyperparameter for the GPT-5 training, and they better get it right? Because if they get it a little off, they could cost millions of dollars, right?
Yes, but you typically learn these values through like trial and error. So you might start with broad steps, like broad chunks for each of those rates, like within reason, but you would choose maybe by a factor of 10 or whatever. And then as you find the model that is the best, then you could like zoom in and make the chunks closer together and closer together and closer together to find the model's hyperparameters that work the best.
Yeah, maybe that's why they can pay $1 million salaries to these people, because it's like, yeah, if you like, who else knows this? And if you get it right, it saves us that much money.
Yeah. But it's also just looking at the performance of the model, right? It's like trying values and then looking at the performance of the model and kind of like trial and error. But yeah, it does take some knowledge of like what are possible.
Can you break down the different frameworks? So I hear things like PyTorch and TensorFlow and scikit-learn. In terms of like packages and programming languages, like what's out there, what should people be learning if they're interested in the field? Which ones do you personally like and use?
Yeah, this is a great question. So they're all different. PyTorch is the most commonly used system right now. It is built on top of Python, and it is a little bit more low level. So actually, let's start with Keras. So Keras is built on top of, it used to be TensorFlow, which made it less useful as TensorFlow became less popular. But I think they just released a new version of Keras, like Keras 3.0, which also works with PyTorch. Anyway, it is an abstraction away from some of the underlying low-level machine learning stuff so that it's easier to code in. But as a result, it's slower, right? Because it's kind of a wrapper around the low-level stuff. TensorFlow is written in C++, written on top of C++, but the actual way you interface with it is with Python, so it's easier to understand and to code in. But people think it is less intuitive to work with than PyTorch. Apparently, they operate about the same, but I have seen some people say that TensorFlow is better for like super large scale systems and deployment and working with many queries. So in that case, you might want to have TensorFlow, but it varies. But what I would say, and then scikit-learn is typically used for Not deep learning, so not using neural networks, not for large language models, but maybe if you want to do some clustering on data, like some unsupervised learning stuff, or like, linear regression models, or types of machine learning, or like, decision trees, whatever, outside of deep learning. So again, neural networks. Scikit-learn isn't used for that as far as I know. Another one that's come out is the Transformers library from Hugging Face. My guides that I have made to fine-tune models use that. It's basically a wrapper around, I think it's PyTorch. And it's kind of similar to Keras in that it's really simple. You just, rather than having to set up the whole model yourself and set up the layers and the loss functions and set everything, you just say you call the trainer class, and then you put in a bunch of parameters into the trainer class, and then you can just say .train, and it'll do it for you. So it abstracts away a lot of the hard stuff. And I find that my guides that use that, the Hugging Face Transformers library, have become super, super, super popular because it just makes it really easy to work with machine learning models. And then also Mojo is a new language for working with machine learning models. It's low level, super fast. That's kind of on the up and up to it works well with PyTorch and Python.
And what were they teaching you at Stanford in computer science for artificial intelligence? TensorFlow for a bit, and then PyTorch. And we used scikit-learn for a few courses and Keras for a few courses. So we were jumping all around. And do you think that's the best for getting a job afterwards, or would you have recommended they teach something else?
Oh, well, that was back in the day. I guess I graduated Stanford in 2022, and I started AI in 2017.
I love how you're back in the day, 2022.
Back in the day, yeah. I'm I guess it wasn't that far away. Yeah, in the machine learning days. Yeah, in AI, it's moving so fast. But I don't know. Right now, you can find, I have a guide on, I'm setting up a Hugging Face Transformers library coding playlist on my YouTube. So if you're interested in that, we have the first video out. It's accessible to people who are not even coders. And basically the first video is just downloading a model off of Hugging Face and running it on a remote GPU. And so you can just chat with a model yourself, not through, choose whatever model you want to learn, open source model you want to work with, and then you download it, and then you can send data to it. And if you are not a coder, this is still accessible to you. So my goal for this playlist of Hugging Face Transformers 101 is to teach people the Transformers library, which I think is amazing. And that's what I'll be using for coding in AI going forward.
What's your thoughts on open source? It seems like Anthropic and Gemini and ChatGPT from OpenAI have all kept kind of closely guarded, their weights and their methods and their architecture. And then it seems like on the other side, you see Grok from Elon Musk and Meta open sourcing, but also kind of a mix of what's open sourced. Sometimes it's not the exact model weights. Sometimes it's not the training data and all of the things that went into training the weights, but it's one or the other. Where do you fall on the spectrum of what the right thing to do is?
I mean, I like open source in the sense that it's really, there's a strong community around it. It helps everyone progress further. It helps, distribute, democratize the ability to use these systems. It, prevents, it's good for antitrust things and not having monopolies. And, but I can see where there's some fears, having these systems be too readily available. They could fall into the hands of the wrong person or whatever. I don't know. I think I like open source. I think Meta has been great in that they are doing a lot for the open source community. They're open sourcing, or at least open, what are they? Is it open weights?
Yeah, I think open weights, because they won't exactly give us every piece of data that it was trained on. I'm guessing that could open them up to certain liabilities of, you trained on the stuff that we uploaded, or potentially on other companies' information or open web stuff.
I think that's great. I think that's really cool. I like that Meta's doing that. I think it's helping us all advance. And we can learn from the architecture of other people. So when people open source their model architectures, we can kind of learn things from that. Like, oh, that model did something weird and they multiplied at that layer rather than, added, or they did this kind of multiplication rather than this kind. And like, I like that. I like that we can all share the knowledge. So I'm a proponent of open source.
Pro open source generally?
Yes, definitely pro open source.
Can you explain agentic workflows to us?
Agentic workflows are systems that are able to use things like APIs so they can have actual actions in the world. So it's like a mix of AI systems that not only have like awareness, but then also you mix actions as well. And yeah, like you could book flights or say like, hey, book this flight for me. And then the system would be not only just say like, okay, but it would also then know, oh, I should call this API and then I should do this and this and this to book it. So they're much more complex to do, very hard to implement, but more and more are cropping up.
And what can you explain the diffusion model architecture versus like what we talked about with large language models and vectors earlier?
Yeah, so diffusion models, they're gradually reducing noise in a data set, typically used for like image. So when they're being trained, they like add noise to an image and then remove it. And so they add it from some distribution, typically like it's a Gaussian distribution, and which is a type of likelihood of, so you're adding noise, you're adding a number or subtracting a number from the original number, because remember, images are made up of numbers. They're just like
pixel values.
Yeah, exactly. RGB. So it's like 3 channels of RGB. So it's a square 2D, 3 channels of that. So it's a value for red, green, blue for each of those pixels. And what you're doing is you're adding noise to each of those values according to this distribution. So you're adding a value according to this distribution. And then what the model needs to do is you add this noise until it's just, you have a picture of a dog, it becomes just static. And then what the model needs to do is to undo that static to bring it back to the dog. And so what you're learning is like how the data is distributed, like how the numbers are distributed. And so what you can kind of do is start with static, and then given like, this is a dog or whatever, you can create images from that, because it's rather than going from image to static back to image, you're just starting with the static and then going to an image. And so that's how like these diffusion models work, like, stable diffusion and DALL-E and things like that.
What other specifically YouTube resources have you been watching? Like what other creators, but sometimes maybe the more technical ones if you're using them to actually like learn and to take tutorials from, and then sometimes more of the kind of creators that give you a more broad perspective?
3 blue, 1 brown.
Oh yeah, 3 blue, 1 brown. Oh my God. Can you make those videos? Because you have to program those videos, I guess, too. I've seen him talk about it.
Yeah, he's awesome. He's really cool. And you can watch his lecture or his graduation speech. I think it was at Stanford. He gave a speech to a graduating class. He's great. I forget the man's name, but awesome. His videos are fantastic. He has some great Transformers explanation videos with great, as you said, graphics. Andrej Karpathy is kind of like the AI educator guy. He was also at Stanford, and he is now starting, I think, an AI education school. So Andrej Karpathy, AndrejKarpathy. Check him out. Like, he is the AI educator.
What about Andrew Ng?
Andrew Ng as well. Yeah. He's got some really famous deep learning courses online, but Andre is more prevalent on like YouTube. He has some, code GPT-3 from scratch videos out there. It's like 3 hours long. He's great. Andrew Ng, I also took a class of his. He is also great. And then I guess like outside of AI, I like Tiffin Tech. She's great. She's on Instagram. She has like general tech knowledge. She's fantastic. There's a bunch of really cool creators on Instagram. Oh, she's also on YouTube as well. And she does some AI stuff. She loves to code. She does cool AI projects. So yeah.
All right, Harper, that was so much fun. Thank you for going into all sorts of weird corners of artificial intelligence with me and explaining how a lot of this works. You've done a great job over on Harper Carroll AI, which is your YouTube channel, but you're also doing a bunch of stuff on other social media platforms. Just give us a quick rundown, like where everybody can find you and what you're going to be teaching in the future.
Yeah, well, thank you. And also, this has been lovely, Dylan. Thank you so much. Really enjoyed our conversation. You asked great questions, and I like the way that you think about things. So thank you for having me. And my Instagram is a main place that I post Harper Carroll AI, 2 R's, 2 L's, like a car rolling down the hill. Harper Carroll AI. And also on YouTube, I will have a lot of long form videos out there. So mainly check out my YouTube if you really want to learn, and then in depth, and then Instagram for short bites about various topics, like pretty much all of the ones that we talked about today. I have little bite-sized info about those. So
yeah, it's great. I get a lot of your stuff on my Instagram too. You're so much better than me or anyone, pretty much anyone I know, that short form education. Like, I love that, just like hyperparameters versus parameters, 60 seconds. Like, okay, I can digest that day after day and feel like I'm learning a lot. So great work with your short form, especially.
Thank you. Thank you. I really, really appreciate that. Thank you.
And then we'll link, in the description, you can like link directly to it, or just type in Harper Carroll, like car rolling down a hill, into YouTube, and you can find her.
2 R's, 2 L's. Yep, exactly. Yeah.
Okay, great. Thank you.
Thanks so much, Dylan. Have a great rest of your day. Take care.